We will now solve problem 7 in the exam given in the fall 2017. In this case, we have a leisure vessel that crosses a river from shore to shore. The speed of the vessel is 4 meters per second eastwards, and the river has northwards currents of 3 meters per second towards north, double north. Okay. And we're asked what is the resultant velocity of the leisure vessel, and we want it in magnitude and direction relative east. So if we look at this, we have 4 meters per second, which is the speed of the vessel, and we have at 3 meters per second as the speed of the currents. The resultant velocity, let's name that V, has some kind of direction, relative east. So since it's relative east, we need to take it between our resultant velocity and eastward direction. So magnitude, you want to find the length of that vector, we could use Pythagoras. So V squared would be the speed of the vessel squared plus the speed of the current squared. So V would be the square root of those. And we could insert them. 4 plus 3, which will give us 5. The direction, using trigonometry, hard word to pronounce sometimes. We could use tangents. Tangents would be the angle here would be the opposite side divided by the tangent side. So that would be the current velocity divided by the velocity of the vessel. So that would be tangent inverse of BC by V. And again, if you use arctang, was simply A tan, that is also okay, it's just different notations. Anyway, our angle would be tangent inverse, or A tan arctang, to 3 divided by 4, which is something like 36.9 degrees. So the resultant velocity is 5 meters per second in direction 36.9 degrees relative east. And I put my answer in text since it is asked in text. B. If the river is 80 meters wide, how much time does it take the leisure vessel to travel shore to shore? Okay, so we start at one side here and we want to get across. The length is now 80 meters and our velocity would be 4 meters per second. the velocity of the river simply carries us down the river and has nothing to do with our crossing. So our velocity would be our length divided by the time. You could see it by, you have 5 meters per second, so you need to have the length divided by the time. So what were we asked for? We were asked for the time. So if we multiply with t and divide by v on both sides, we get t equal to L over v, which would be 80 meters divided by 4 meters per second. So it takes only 20 seconds. Which makes sense, because if we have 4 meters per second, you will get 4 meters the first 8. You get 4, 8, 12, and then 16, and then 20 after 1, 2, 3, 4, 5 seconds, and so on, up to 20 seconds, where we get 80 meters. In C, at what distance downstream does the leisure vessel reach the opposite side? Okay, so what we have now is that our vessel uses 20 seconds to get from one shore to the other shore. In this, meanwhile, the current drags the vessel downstream. So the distance, the currents drag the vessel downstream during 20 seconds is, if we call that x, for example, you would get the speed of the currents multiplied by the time it takes. So we have 3 meters per second times 20 seconds that it takes to cross, and we get 60 meters downstream. You could also use trigonometry. Say that x would be L tangent to theta equals to 60 meters.